Good morning, ma'am. Good morning, classmates. To continue our topic about the evaluation of science learning, so my task is to discuss the test of developed abilities in science. So our objectives for this morning, first we will discuss the planning for assessment, followed by managing classroom assessment, and the last will be the types of classroom assessment. These will be the formative and summative assessment. So what is the role of classroom assessment in science education? Classroom assessment is an integral part of science instruction. So we all know that assessment is very important in science instruction because assessment is an ongoing process of understanding and improving student learning. Classroom assessment is broadly defined as any activity or experience that provides information about student learning. So the primary purpose of classroom assessment is not to evaluate and classify student performance, but to inform teaching and improve learning, and to monitor student progress in achieving learning outcomes at the end of a grade. Next, w- as a teacher, why do we need to plan our assessment? Since assessment is an integral part of instruction, teachers should plan it at the beginning a unit of study. We teachers select assessment purposes, approaches, and tools in conjunction with our choice of instructional strategies. In developing assessment tasks and methods, teachers determine what they are assessing or what we are assessing, what they are assessing, how the assessment information will be used, who will receive the assessment information, what assessment activities, tasks will allow students to demonstrate their learning in authentic ways. Next, let's proceed to characteristics of effective assessment. So I have here seven effective assessment. First, effective assessment is congruent with instruction and integral to it. Effective assessment is based on authentic tasks and meaningful science learning processes and context. Effective assessment is multidimensional and uses wide range of tools and methods. Effective assessment is based on criteria that students know and understand, appealing to their strengths. Next, effective assessment is a collaborative process involving students. Effective assessment is focused on what students have learned and can do. And the last, effective assessment is ongoing and continuous. So we'll discuss this one by one. Next, effective assessment is congruent with instruction and integral to it. Assessment requires teachers to always be aware of the questions. How teachers assess depends on what we are assessing, whether we are assessing declarative knowledge or procedural knowledge. So what is declarative knowledge? It is defined as questions that assess pure recall of specific isolated pieces of knowledge, such as facts, definitions, and terminologies. While procedural knowledge is defined as questions that assess problem-solving skills in understanding concepts and assembling knowledge. So when I say declarative knowledge, it promotes surface learning. So more on memorizing facts, definition of terms, terminologies. While procedural knowledge, it promotes deep learning. So madulom-dalom gawa. So these are understanding concepts or problem-solving skills. Okay? So when I say declarative, surface learning medyo hapaw compared to procedural knowledge, which is the deep learning. Effective assessment is based on authentic tasks in meaningful science learning processes and context. Assessment tasks in science should be authentic and meaningful, tasks worth mastering for their own sake rather than tasks designed simply to demonstrate student proficiency for teachers and others. So, authentic assessment tasks are not only to tests of information students possess, but also of the way their understanding of subject and of their ability to apply learning. Next, effective assessment is multidimensional and uses a wide range of tools and methods. Assessment in science must recognize the complexity and holistic nature of learning for scientific literacy. To compile a complete profile of each student's progress, teachers gather data using many different means over numerous occasions. Student profiles may involve both students and teachers in data gathering and assessment. So I have here a chart that identifies areas for assessment and some suggested assessment instruments, tools, and methods. So I have here an example of data gathering profile. So it includes observation of process, observation of products and performances, classroom test, divisional and provincial standard test. So in the observation of process, we have two factors, the teacher and the students. For teachers, we have checklists, conferences and interviews, anecdotal comments and records, reviews of drafts and revisions, oral presentations. For the students, they have journal, self-assessment, peer assessment. In the observation of products and performances, in teachers, we have written assignments, demonstrations, seminars, portfolios. For students, they have journal, self-assessment, peer assessment. For classroom test, for teachers, we have paper and pencil test, performance test and simulations. For students, they have journals and self-assessment. For divisional and provincial standard tests, teachers, markers, students, rubrics and marking scales. Next, effective assessment is based on criteria that students know and understand appealing to their strengths. Assessment criteria must be clearly established and made explicit to students before an assignment or test so students can focus their efforts. Students need to be involved in developing assessment criteria. Students should understand clearly what successful accomplishment of each proposed test look like. Models of students' work from previous years and other exemplars assist students in developing personal learning goals. Next, effective assessment is a collaborative process involving students. The ultimate purpose of assessment is enable to students assess themselves. The gradual increase of student responsibility for assessment is aimed at developing students' autonomy as lifelong learners. So it helps them to make judgments about their own learning and provides them with information for goal setting and self-monitoring. Next, effective assessment is focused on what students have learned and can do. Assessment must be equitable. It must be offer opportunities for success to every student. Effective assessment demonstrates the knowledge, skills, and attitudes and strategies of each student and the progress of the student is making, rather than simply identifying deficits in learning. So to assess what students have learned and can do, we teachers need to use variety of strategies and approaches like use assessment tools appropriate for assessing individual and unique products, processes, and performances. The last is effective assessment is ongoing and continuous. Teachers provide informal assessment by questioning students and offering comments. They also conduct formal assessment various stages of project or unit of study. So we teachers, we need to review and revise our instruction content, process, emphasis, and learning resources. So as a teacher, what makes a good classroom assessment? So let's proceed to managing classroom assessment. So assessment is one of the greatest challenges science teachers face. The practices that make science classroom vital and effective. Promoting students' choice, assessing processes, and assessing the subjective aspects of learning make assessment a complex matter. So system and supports that may assist teachers in managing assessment includes assessing what is most highly valued rather than assessing what is easily measured. Assessing rich, well-structured knowledge rather than assessing discrete knowledge. Assessing scientific understanding and reasoning than assessing scientific knowledge only. Assessing to learn what students do understand than rather than assessing to learn what students do not know. Assessing achievement and opportunity to learn rather than assessing only achievement. Students engage in ongoing assessment of their work and that of others rather than end of unit of term assessment by teachers. And the last, teachers involved in developing of external assessment rather than development of external assessments by measurement experts alone. So how learners or students assess in classroom? So assessment in science can take many forms but broadly involves assessment for learning, which is the formative, and assessment of learning, which is the summative assessment. So let's proceed to the types of classroom assessment, the formative and the summative assessment. So formative assessment, so what is the purpose of the formative assessment? To promote further improvement of student learning during the learning process, to involve students in the ongoing assessment of their own achievement, while the summative assessment, to measure student achievement at a point in time for reporting and accountability, to sort students in rank order, to maximize students' learning through standardized tests. So when we say formative assessment, it is planned and used during instruction and discussion, while the summative assessment, it is after instruction or this discussion. So a we have the differences and similarities of formative and summative assessment. So for the differences between the formative assessment and summative assessment, for the formative assessment, so the examples are quizzes, observations, classwork or homework. For the summative assessment, we have the end unit chapter test, the end term or semester exams, or scores that are used for accountability. Formative and assessment have similarities. So both are ways to assess, both are questioning strategies need to be addressed, both need to be used to evaluate a student effectively, both can be used for student feedback, and both assist in future lesson planning. Let's proceed to assessment strategies that can be used in the science classroom. So first we have the observation. So observation of student is an integral part of assessment process. It is the most effective when focused on skills, concepts, and attitudes. Next, we have interviews. Interviews allow teachers to assess an individual understanding and achievement of the prescribed student learning outcomes. Interviews provide students with opportunities to model and explain their understandings. Next, group or peer assessment. Group assessment gives students opportunities to assess how they will work within the group. Peer assessment gives them opportunity to reflect on one another's work according to clearly established criteria. Next, we have the self-assessment. Self-assessment is a vital to all learning and therefore integral to the assessment process. Each student should be encouraged to assess her or his own work. Performance assessment or student demonstrations. Performance tests provide students with opportunities to demonstrate their knowledge, thinking processes, and skill development. Next, science journal entries. Science journal writing provides opportunities for students to reflect on their learning and to demonstrate their understanding using pictures, drawings, and words. Rubrics or checklists. Rubrics and checklists are tools that identify the criteria upon which student processes, performances, or products will be assessed. Will be assessed. Visual displays. When students or student groups prepare visual displays, they are involved in processing information and producing a knowledge framework. Laboratory report. Laboratory reports allow teachers to gauge the ability of the students to observe, record, and interpret experimental results. Pencil and paper test. Quizzes can be used as discrete assessment tools, and tests can be larger assessment experiences. And the last is the research report and presentation. Research projects allow students to achieve the learning outcomes in the individual ways. Assessment should be built into the project at the every stage from planning to researching to presenting the finished product. So that's all. Thank you for listening. Questions?